We're back at it. This time we're going to do systems of equations, but we're not going to graph them. We're going to solve it algebraically using a method known as substitution. Now, just like you know you can substitute numbers in for variables, you can substitute entire expressions as well. And we're going to use that method to figure out what is the solution to this system of equations. 2x plus 5y is 20, and x equals y plus 3. Now, you'll notice that the bottom equation is already solved for x. See, x equals y plus 3. And we're going to take advantage of that because what we're looking for is where two lines intersect each other. And where they intersect, they have the same x value and they have the same y value, just like when you were doing graphing yesterday. So the x value here is going to be the same as the x value here where they intersect. So I'm going to take y plus 3 and I'm going to substitute it in for x in the first equation. So I've got 2, x comes out and I replace it with y plus 3, and then I write the rest of the equation, equals 20. So the x is gone, but I've replaced it with something that is equal to x. Distribute the 2, you get 2y plus 6 plus 5y equals 20. Combine the 2y and the 5y to make 7y plus 6 equals 20. Subtract 6 from both sides. You get 7y equals 14. And when you divide both sides by 7, you get y is equal to 2. Now remember, that's only half the answer. We have to go figure out what x is. And you can plug that y value into either one of these equations to figure that out. I think it's easier to do the second equation because it's already solved for x. It's very easy to go x equals y plus 3. That came from right there. Put in the y of 2. 2 plus 3 is 5. So my answer is 5, 2. This is where these two graphs would intersect if we graphed them. It's also the point which is true for both these equations, all right? Look at the wording here. Find the ordered pair that is true for both equations. This is the only ordered pair that will work in both the first equation and the second equation. That's why I wrote it differently. You want to be exposed to different ways of asking the same question. All right, so that was example Pluto. Now let's look at example Goofy. See, the first one, x was solved for something, but down here, y is solved for something. Doesn't change the method, it just changed where I substituted in. Y equals negative 2x plus 9. That's going to go in for that y value. So I go 7x minus 8. Now I'm going to take out the y, and I'm going to put in negative 2x plus 9 equals 112. Okay? So distribute the 8, negative 8, and you get 7x plus 16x minus 72 equals 112. Combine the 7x and the 16x, you get 23x minus 72 equals 112. Now we add 72 to both sides, and 23x equals 184. And if we divide both sides by 23, x equals 8. Again, that's half the answer. We're going to take the 8, put it into this expression, which is already solved for y, and I get y equals negative 2 times 8 plus 9, which is negative 16 plus 9, which is negative 7. So the solution to this system of equations is 8, negative 7. Okay, so there's the solution. Got one more to do for you. Oh, it looks like two more. Okay, so this is example Donald. Now, you'll notice both of these are in slope-intercept form, right? Y equals 1/2 x plus 6, and y equals 3/4 x plus 3. Well, remember the reflexive property, y equals y? Okay, well, I'm going to let this y right here be the 1/2 x plus 6. And I'm going to let the other y be the second equation, 3/4 x plus 3. So y equals y becomes 1/2 x plus 6 equals 3/4 x plus 3. Now, let's get rid of the denominator by multiplying everything by the least common denominator, which is 4. So we have to distribute the 4 to every term. Okay, 4 times 1/2 is 2, so that's 2x plus 4 times 6 is 24 equals 4 times 3/4 is 3, so that's 3x plus, and 4 times 3 is 12. Let's go ahead and take 2x away from both sides, so 24 equals x plus 12. Subtract 12 from both sides, and you now have a value for x. And it doesn't matter which one of these two you plug it into. Just pick the one you think the arithmetic is easiest. And I would pick the first one, but that's just me. Maybe you'd pick the second one. You'd get the same answer. So y equals 1/2 x plus 6 becomes 1/2 times 12 plus 6, which is 6 plus 6, which is 12. So the answer here is 12, 12. That's the solution to this system of equations. One more example, because again, remember this was different than the last two. The last two, only one was solved for a variable. This one, they were both solved for a variable. And the last example I want to show you is what happens if neither one is solved for a variable. You've got 4 options. You can solve for that x, that y, that x, or that y. Personally, I'm always going to go for the variable that's standalone. It just makes the arithmetic a little bit easier. Okay, so I would take x plus 4y equals -4, and I would subtract 4y from both sides. Okay, and you get x equals, now we're not putting it into slope-intercept form, so I can write -4 minus 4y, or I can write -4y minus 4, both the same. I'm just in a habit of always putting the variable term first, so I would say that x is equal to -4y minus 4. Now, this is what x is equivalent to, so I can plug this back in there, into the first equation. Now this is something to note. Because I used the second equation to generate this, I wouldn't plug it back into itself. You would get an identity. You have to, if you pick one equation to solve for variable, you have to plug it into the other equation. So we can go 3, take out the x, and put in -4y minus 4. Then write the rest of the equation, plus 5y equals 2, and we will solve that. So this becomes -12y minus 12 plus 5y equals 2. We're going to combine the like terms. -7y minus 12 equals 2. We're going to add 12 to both sides. So we get -7y equals 14. Divide both sides by -7, and y equals -2. Okay, so there's my y value. And I already took the time to solve this for x, so I'm going to plug that y in here, and it will tell me what x is. X equals -4y minus 4. So that's -4 times -2 minus 4, which is 8 minus 4, which is 4. So my ordered pair is 4, -2. And there's an example of what you do if neither one of the equations is solved for a variable. You're going to have to take the time to do that before you can do the substitution. Okay, so you had 4 different examples. They're all different in one